In this video, we're going to continue our introduction to the Arduino by looking at some of the other basic things that we're going to need. So at this point, we have the Arduino software installed, and we were able to run a simple program on it and look at the outputs using the serial monitor. And importantly, what we looked at was some of the very useful functions such as serial.begin, serial.print, serial.println, and delay. And so these are the ones that you're going to use quite a bit when you do this stuff. Okay, but what else do we need? So if you're going to be doing any computer program, you're also going to need to look at things like data types and how the data types are used when you assign them to other variables. And we also got to look at the notion of global and local variables. And then we also want to look at simple math operations, making decisions using if, then, and case statements. And of course we need loops, and there's two really common loops, for and while loops. And we can use loops to enter information into the serial monitor, which is kind of neat. And then finally comments. And then once we get through this, then it's basically looking at just using the Arduino to actually accomplish real tasks. So let's start off by looking at data types. The Arduino supports the common data types that you might think about. Int for integer, float, double, char for character, and string. One important thing, string has a capital S. So remember, Arduino is case sensitive when you program. And what's neat about it is that the print function works directly on these. So in addition to being able to print out a message to the serial monitor, you can just say print and then put the variable name in it, and it automatically recognizes what type it is, and then it'll pop it out. And where we define these things, whether it's in the setup or the loop routines, is going to dictate whether it's a local or a global variable. And then additionally, conversions are also possible. So there's a number of they call it casting when you change something from like a float to an integer, or vice versa. And then so there's functions for that. And then there's also ways to convert strings to integers and strings to float. And this becomes super useful when you read information from the serial monitor. So the serial monitor, if you remember, it's always sending ASCII codes. So if you type the letter, A, it's going to come up as some ASCII code like 50 or something. And what'll happen, I don't know if it's 50, but something like that, and it'll come up and you can't use that directly as a number. So, or let me a better way of saying it is if you typed in 3 and sent it up the UART, it would be interpreted as the ASCII code for the symbol 3, not necessarily the number 3. And so you would have to convert it to int in order to use 3 in an operation. So anyway, let's take a look at some examples here of how we use this. So I'm going to fire up a new sketch, and we'll put it right here. And then what we'll do is we've got our void setup and our void loop, which are good. And let's just start off by making some basic variables, and we'll see what happens when we try to print them and do stuff like that. So let's go ahead and do a serial.begin 9600 to set up the serial connection to the Arduino. And then I'm going to go ahead and I'm going to create an int called A, and I'm going to give it a number of 22. Okay, so I just have created an integer, which is variable A. Let's go ahead and make a float, which is going to be B, and a float, remember, is a real number, so I can do something like 3.14. And then just to complete the example, let's do a char, which will be C, and a char is a single symbol, so let's do something like E, so we'll actually assign it the letter E. And then if I want to do a string, this is where, let's call it S1, what we can do is say, I can actually put double quotes and say, I am here. Okay, so we have just now set up 4 variables, and we've assigned them 4 of the most common types that you use in your program. So let's go ahead and see what happens when I try to actually, or let's see how I can actually print these. So what I'm going to do is let's print the value of A to the serial monitor and see what happens. So in Arduino, you can't use a printf. There's not a built-in printf. So what you have to do is when you do a print, I'm going to do just a regular print, you have to put your message separate from the actual variable value. So for an example, I'm going to do something like this. I'm going to say A is this. And then I'm going to then put another line where I say serial print, and all I do is I just put A in the parentheses, and I'm off and running. So let's go ahead and fire this up. One of the things that asked me is, hey, I need to save this. So let's go ahead and do a file, save as, and I'll come over here to my desktop where I have my Arduino folder, and I'm going to come in here and I'll just go ahead and say activity 3 data types, and we'll go ahead and save that off. Okay, so I'm going to go ahead and run this, and it's going along here. Everything's great. It's going to download it, and then what I need to do is bring up the serial monitor. And here's our serial monitor. So let's go ahead and look at what happened. Okay, so it says A is 22. Great. All right. So notice that I could just print A directly by having serial print. Okay, let's go ahead and do a couple more. So serial print, B. B is, and then I put a space there and do that, and I go serial dot print B, and let's go ahead and do all of them just to kind of show what we're doing here. So then we got C is something, and then we'll go S1 is S1. Okay, so let's save that and see what ends up happening there. Okay, so it popped out, and it wasn't very nice because it said A is 22, B is 3.14, C is E, S1 is I am here. Notice that I didn't put line returns in here. If I wanted to put a line return in here, what I could do is I could do it two ways. I could say serial.print, and I could actually do /n, and then that would do a line, or I could actually come in here and change all these to print line, and then that would put it in there. Okay. All right. So let's do that one. Oops. Line. So let's go ahead and run that and see how that looks. Okay, so now it's going to fire off, and boom, there it is. So you see how all these things worked. So this is pretty straightforward, pretty easy. One of the things that's interesting is that I've defined these these variables inside of the setup loop. So if I came down here into the void loop and I said I just want to print out I am here over and over and over. So I'm going to go print ln, and then I'm going to say S1, so I'm going to print my string, and let's take a look at what happens here. So I'm going to go ahead and verify this and compile it, and it errors out. It says S1 was not defined in the scope. What that means is that you defined these variables inside of the setup loop. Well, the loop or the loop scope is what they call it, it can't see inside of here. So this is the concept of a local variable. This variable is local only to the setup routine. So down here, loop can't see it. And that's kind of neat because you can actually have the same variable name. So if I came down here and I said string1 is equal to not here, and I did something like this, I could say, okay, now I'm going to do this, and I'm going to fire this off. And what I was able to do is I used the same variable name in two different scopes. So in one situation, now it's off and running here, but if I can look back at the top, let's see if I can do it. You can't do it. Let's do this. Let's go delay 1000, and let's go ahead and save that. So now in this situation, what it's going to do is this local variable S1 is I am here, and that'll be printed first, and then so it's I am here, and then down here this is a totally separate variable, separate local variable within the loop scope that is also not here, or is something different. Okay, so two different variables. Anyway, this is the concept of a local versus a global variable. If I wanted a global variable, that means that it is seen absolutely by everything in my code or everything in this program. What I can do is I can come out here. So I can do something like, okay, I'm going to say string S2 is equal to really here. And now I've set that up, and let's go ahead and see if that'll work. Let's verify that first. And so that's gonna set up this new variable, and it's like, okay, life is good. And now let's go down here and let's see if both of them can see it. So I'm going to go ahead and say S2 is, and then print line S2, and then I'm going to do the exact same thing in the loop scope. Okay, so I come down here, I'm going to print this, and if this works, that means that S2 is indeed a global variable. Okay, and then this is an important concept because you can really get confused, and you can really get the wrong results if you don't track where a variable is defined and how it is actually used. Okay, so this now is notice that it's going, I'm here, S2 is really here, not here, so it's like this was the first instantiation of it, and then these are the looping ones. So everything worked out great. Okay, so this is fantastic. Let's look at one last concept, and that is changing data types. So I'm going to come back over here, and I'll go ahead and delete these, and we'll go back up. And we have ints and floats and characters and stuff like that, and this is great. What if I wanted to take b, which is a float, and I wanted to convert it to an integer? Okay. Well, the way that this works is you simply, I'm going to do this. I'm going to go serial.print, and I'm going to say a is, and we're going to print the original value of it, so it'll print out 22. And then I'm going to do the following. I am now going to assign, I'm going to take b, and I'm going to convert it to an integer and stick it into a. And you do this using a cast. Okay, so cast is the term you use when you convert data types to other data types. So what I can do is I can say a is going to equal, and then what I do is I put in parentheses here the type I want to convert the argument to. So if you look at this, what I'm going to do is I'm going to assign b to a, but b is a float, so I have to convert it to an integer, and the way I do it is I just simply put that right there. So I put this parentheses int, and that's the syntax for a cast. So now if I do this again, if I do this print, it should reflect what the new a is. So now if you think about this while I download it, 3.14, the 0.14 can't exist in an integer. Okay, that's a real number. So what it's going to do is it's going to basically chop off any of the decimal or the fractional digits. So notice that this represented a is 22, the integer. This one is now a is 3. So no matter what it is, it'll just chop it off. It doesn't round it or anything like that. It just chops it off. So that's the concept of data types. Is it's got these common ones in there, but you can also define them in the loop or the setup scope, and they will only be seen within those scopes, or you can create a global variable, and then you can convert back and forth using typecast or actual function calls. Okay, so that becomes very important. So at this point, why don't you do an activity where you pause the video and play around with defining some of these common types and experiment with putting them inside of setup or in loop, and then trying to call them from the other one and seeing how the local variable setup works, and then also try to play around with just defining a global variable that everybody can see. Okay, so now we have done that. We've got our data types. So let's look at some simple math operations. Arduino supports simple math operations, the addition, subtraction, multiplication, and division, and it works on both int and float / double. And what that means is that if you take, you can do a plus b, and if both a and b are integers, it will use the integer addition circuitry within the microprocessor. If they are both floats, it will use the floating point circuit inside of the microprocessor. What's really neat is that from a programmer's perspective, you don't even need to know what's going on in the processor. You just allow the compiler to figure it out for you. So that's great. The other thing is that more complex, mathematical operations like square root and sine and cosine, stuff like that, they are also available, but they are provided through functions. Okay, so let's take a look at how this might work. So I can take my original, code here, and we won't just create a new project. We'll just keep going. So let's go ahead and say a let's see. So when you do, you can do, when you create a variable, you can either say int a and it'll be blank and then you have to initialize it. So what I'm going to do is I'm going to create 3 integers, a, b, and c. and that's fine. And then let's just show you that I can go a is equal to 1, b is equal to 2, and then what I'm going to do is I'll add those together and then see if it works. Okay, so down here what I'm going to do is say, let's first print out what a is. So print a is a. Okay, so it's going to print that a is equal to 1 and didn't do a carriage return. And then I'm going to do b is b, and so I'm going to print that b is that. And then I'm going to go ahead and I'm just going to say c is equal to a plus b. And then I'm going to come down here and I'm going to say, I'm going to type out a plus b is, and then I'll print what c was. Okay, so then this mathematical result should work. So let's go ahead and do this little simple operation. And we'll pull up the serial monitor, and we'll see what happens. A is 1, b is 2, a plus b is 3. And 3 in this situation was, it was the the variable c. Okay, so you got this math operation, everything's great. When you do division, it's going to expect you to use floats. It'll actually convert integers to floats if you try to do 2, an addition with the 2 different ones there. But it's cool to keep in mind all the math operations that you have in there. So go ahead and play around with some of these operations, plus and minus and all that sort of stuff. And when you do, think about actually negative numbers too, because if I did a minus b, I should actually get a negative number. And you say, well, I don't know, is that going to work? So let's go ahead and fire that up and see if it will work. And so when you do math with a computer, you're always thinking about, okay, the destination variable, is it going to be able to hold that value? So is it possible for the variable c, being of type int or integer, to hold the value -1? And it is indeed possible. Okay, an integer can go from up to a positive number down to a negative number depending on how many bits that the computer is. Okay, so in this case, just keep in mind that integers can absolutely be negative. Okay, so go ahead and play around with that, and then go ahead and mess around with some of the functions like square root and POW. These are, POW is power, but it's a good exercise to say, okay, well, POW, what do I need to do? What you need to do is then go out to the Arduino reference website and type that in, and it'll pop up and it'll show you exactly what the arguments are. So go ahead and pause the video and play around with that. Okay, so now we've got our math, and it's time to start looking at making decisions. All right, now when you make decisions with an Arduino, there's kind of two primary ways to do it. You either do it with an if-then, or you do it with a case statement or a switch case statement. The if-then is probably the most common. You basically say if, and then you provide it in parentheses a Boolean condition. Boolean means it's either true or it's false. So when you do something like if a is equal to 2, as an example, if it's in this Boolean position here, it's not going to assign the letter or the number 2 to a. What it's going to say is a equal to 2? And the answer can only be yes or no, or true or false. So that's how whatever expression you put here is interpreted when you use an if. And so we call it a Boolean condition, because Boolean means either true or false. And the way it works is that if it's true, it'll do the first clause that's or it'll execute the statements within the first set of curly brackets. If it's not true, it'll pop down here to this else keyword, and it'll do whatever statements you've listed inside of the bottom curly brackets. And what's neat about this is that you can just keep adding else. You can add another if right here and then do another else, and you can keep cascading them together to make more and more advanced programs. Okay, so let's do one. Well, let's do this here. Let's pop up our project and let's see how this will work. All right, so I've got int a b. Let's just do some comparisons here and see what this is. So I'm going to leave that it's going to print A is something and B is something. And now I'm going to come down here, and what I want to do is create a Boolean condition where, let's say that if A is greater than B, it'll print A is greater than B. Otherwise, it'll print B is greater than A. And then what we can do is we can change the values of the variable itself, and we can see how it executes one versus the other. So let's start off and say if, and then it's going to say, let's type A is greater than B. And what I'm going to do is I will then type serial print, and let's do a print line. Print line. And I'm going to say A is greater than B. Okay? And if the Boolean condition A is greater than B is true, it'll say A is greater than B. Okay? What will it do if it's not true? Well, then we're going to do else. We can do serial print line, and then we would type B is greater than A. Okay, so those are our situations, and all I got to do is remember these curly brackets, and it should be ready to go. All right, so let's see what happens here. So this should work. I'm going to bring up our serial monitor again. And now in this situation, it typed A is 1, B is 2, and it said B is greater than A. Now, if you look at this situation, it evaluated this if A is greater than B, and it said that's false. Okay, that's not true in this situation. So it did not execute the statements in the first curly bracket. What it did is it says otherwise, it went down to this else, and it printed this. So if I want to make sure that this logic actually works, I can actually come up here, and let's go ahead and make A bigger than B. And now in this situation, it should print A is greater than B. Okay, so this should be okay. And then that will verify that our logic is there. Okay, A is greater than B. Life is good. Now, how could you cascade these together? Well, one of the things you could do is you could say, I'm interested in not only if A is greater than B, I'm also interested if it's equal to B. So I could actually come in here and I could say, okay, if A is greater than B, print A is greater than B. Else, if, and now what I've done by adding that additional if is I have given myself another possibility to add an else. Okay, so if you think about it, this right here is a completely separate if-then statement or if-else statement, but it's nested under the else clause right here. All right, so I'm going to be able to have two Boolean conditions that I'm going to test. So in this situation, why don't we say if, and I'm going to say B is greater than A, I will say B is greater than A. And then finally, so I can print for specifically when A is greater than B, specifically for when B is greater than A, but now what that allowed me to do is I can come here and I can do a print line of B, let's say A is equal to B. All right, so now we've added a second Boolean condition, and it allows us to cover 3 cases. All right, so let's see if this works. And so we're testing the case where A is greater than B. All right, that's good. Let's go ahead now and test the case where they're equal to each other. And it worked. Okay, and it takes about 10 seconds to compile those things. Okay, life is good. So we have an if-then statement, and you're going to use these like crazy. Okay, another really popular one, same functionality as an if-then, but if you have a lot of different Boolean conditions that you want to do, you can use a switch case statement. And the way that you do that is you say switch, and then you list the variable, and then you list case 1. And for case 1, what you do is then you list do something when it equals 1. And so the way that you would do that is you would say case, well, let's just do it. So let's go in here and let's test A. Okay, so let's do a case statement where I'm going to do an A. And so I'm going to nuke my nuke these guys right there. And what I'm going to do is I'm going to take a look at the value of A. Okay, so I'm going to look at the syntax on this, and I'm going to say switch, and the variable I'm going to look at is A. And then I'm going to open up a curly, and I closed a curly, and then I'm going to come here and I'm going to say case. I'm going to say if it is equal to 1, and then what I'm going to do is go serial.print, and then I'll say print line, and then what I'm going to do is say A is 1, and that's it. Okay, and then what I can do is I can come here and I can do it again and check to see if it is 4. Okay, so let's do that, and I can print something different. So it's kind of like an if-then statement. Okay, but the cool thing about it is that you have to include these things. You have to include these things called break, and that means that once it does its thing, it's going to jump out of the switch statement. And then, so basically, after this, what I would do is I would come over here and I'd say break, and then after this one, I would do break. And then what's cool about it is that I can have a default where if it's neither of these, then what I can say is I can have something here where I'd say serial print line, and I'd say A is neither 1 or 4. Okay, and that would be the case when it's not done, or not either of this. And then I'll come over here and I'll do a break, and then of course you got to come down here, and that should work. Okay, so let's take a look at this. Let's pop it off and see if it's going to work. We'll bring up our serial monitor, and in this situation it says it should basically say A is equal to 4, or A is 4. Okay, so A is 4, and then this is what the case statement gave us. So these are pretty handy. Let's go ahead and change this to 3 and see if it takes the default route. Okay, so that should pop that, and in this situation then it takes the default. Okay, great. So we have actually made a decision, and those are the two most common ones you use: if then, and cases. And cases are really good when you have a lot of different things you want to check. So why don't you go ahead and pause the video and experiment with playing with some simple if-else statements. So do exactly what I did just to get used to the way the syntax works, and then try a couple switch case statements. Just do a simple one just like I did, and just to get familiar with what you're actually going to be doing. Okay, now one of the last pieces that we need are loops. Okay, so loops are where you run in a circle, and now when you look at the Arduino, you might say to yourself, well, you've got a loop down here, and this is actually a loop. It will loop absolutely no matter what, and you always have that for your use. But sometimes you want conditional loops, so you want something like a for loop or a while loop that will execute a certain number of times or only execute when things happen. The syntax for this for loop is very similar to other programming languages. You do a keyword for, and then you're going to provide a loop variable, and you're going to initialize it, and then you're going to say, you're going to have a test, which you, each time through the loop, you'll see if it's made it to a limit. So, and then what you'll do is you'll increment or decrement the loop variable. And you can use plus plus. In this situation, you can use x plus plus, or you can use like x equals x plus 1, or x equals x plus 2, whatever. And then what it'll do is it'll go through the loop a certain number of times. Okay, so let's do an example of a for loop. So let me nuke all this, and I'm just going to flat out come in here and put a for loop straight in there. So let's go ahead and say, let's do a for loop that'll just print 1 or 0 through 10. Okay, so I'm going to go 4, and I'm going to have a loop variable, and I'm going to call it I. Okay, so I can define I as an integer right in the for loop. So this is kind of a popular way to do it. I mean, I just created I as a variable, and I had to tell it was int. I could have done int I up here, but I just decided I'm just going to throw it all in the same for loop. And what I'll do is give it its test condition, which is I is less than, let's say, 10, and then I'll do we'll do I plus plus, so it's, you know, going to increment by 1. Okay, so now what is this going to do? Well, here's what it's going to do. It'll go through this loop, basically 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to 10, and for each time, let's we can actually print it. So I'm going to say print with a carriage return I. Okay, so I'll go ahead and get rid of all this stuff up here that we're not using anymore, and let's see how this works. So this is pretty slick. It'll come through. Not so slick. I had a error here. Oh, sorry. Serial. That print. Okay, and we pop that baby up. Okay, so it worked there. Life is good. And it's going to come over here, and it printed 10 times. Notice that I'm putting this in the setup scope, so it's only going to run one time. If I would have put it down here, it would have ran forever. And here, let me do that right now and show you how I could actually do it by run it by 2. So I don't have to always increment just by 1. I can increment it by 2. So let's fire this baby up, and it'll count 1 up to 10. And it's less than or equal to 10, and then it'll go into this, and it's going forever. So see how it's just flying along there, and that's because I didn't put delay. So let's put a 100 millisecond delay in there, and let's fire that up. So I'm feeling really good about my loops. Everything, I have a for loop. I'm going to use those like crazy. While loops are the other situation. So look at this here. Now it's popping away. Let me reset my Arduino and start from scratch here. So see how it started with 1, 2, 3, 4, 5. Okay, so watch right here. It's going to start. It finishes what it's doing, and off and running. Okay, so oh, I didn't put the delay here. Is why it went so fast. Delay 100, and fire that off. Okay. So this is great. Life is good now, and it did the first for loop, 0 to 10, and then it started counting by 2s. Awesome. Okay, so let's do another loop, which is really popular, which is a while loop. So let me nuke the ever repeating one, and let's see how we can do a while loop to do the exact same thing. So I'm actually going to delete this entire thing, and I'm going to create a loop that'll count up using a while loop. So let's create a variable called j this time, and let's go ahead and initialize it to 0. And so I have this j, and what I do is I do while, and I provided a Boolean condition. Okay, so I provided a Boolean condition, and if it's true, it will execute whatever you list. If it's not true, it won't execute that. And so I'm going to come up here and I'm going to say while, let's go j is less than 100. Then what I'm going to do is I'm going to open up a curly, and I'm going to say print line j, and then I'll do a delay, and I'll do 100. Let's do 200, make it nice and easy. And then this will just sit there forever because the j is 0. But I can actually, within the while loop, I can actually increment this. So let's increment it by 3, for example. And let's think about what's happening here. So you're going to evaluate while, and you always got to have this serial in here. So let's pop that off and let's see how this goes. So it's going to evaluate, is j less than 100? If it is, it'll do this. If it's not, it will just skip this thing and be done. Okay, so it'll just sit there and be done. So when I have this in the loop, so look at how nice this is. It starts at 0, 3, 6, and it's going to go all the way up to 100. It did it, done, and it stopped. If I would have put this back down into here, I would have gone up to there, and then I would have started over and basically cleared the loop variable out and continued. So while loops are super handy. Okay, so while loops are great. Okay, so you got your loop structures, and fantastic. Okay, so everything is so great. So let's think about something really cool that I can do with a while loop, and that is I can actually now read from the console. Okay, so how are we going to do that? So it turns out there is a function. So the problem with trying to read from the console using an Arduino is that the Arduino does not have the gets. Okay, so it doesn't have gets function. So because it's not a standard I/O, it's not a keyboard mouse like in a general computer. So it's not going to have this ability to just sit there and read from the keyboard. What you're reading from is this serial UART cable or the USB cable. And the way that those works are you can go out and you can read from it. So there is a function called serial read. Unfortunately, when you call that, it doesn't sit and wait. It just goes and immediately sees if anything has been sent, and unless it's being sent at the instant that you called the function read, it will just return a 0 and say, I didn't see anything. Okay. So this by itself is really worthless. However, when used in conjunction with the while statement and another function called serial.available, you can actually read from it. And so here's the logic behind it. What you're going to do is you're going to say, I want to have the user enter something from the serial monitor and then upload it to the Arduino. So you're going to say enter an integer. And then what you do is you do a while statement. And this serial.available, the way that it works is if something out there is not sending information, if there's no information on the serial port, it'll return a 0. So what happens here is this will sit in this loop until something is entered. Okay, so it'll just sit here, and this is a true situation. So it's just like sitting in these little curly brackets. Okay, and so you can think about it, this line of code is just executing indefinitely until somebody enters something. If you enter something, then this function will say, hey, there's something there, and it won't return a 0. And that'll allow you to come out of this function, and then you can do something. So what we will do then is we will use this serial read, and we will assign it to a variable. And then what we can do is print the variable and see what happens. Okay, so let's try that. So let's go in here and let's go back to our code and let's take a look. I'm going to put this over here so I can see the do it. So the first thing I'm going to do is I'm going to make a car, which is going to be vn, and I'll go ahead and I'm not even going to initialize it. Okay, so I'm just going to sit there, and then what I'm going to do is I'm going to go serial print. I'm going to say enter an integer, and we'll think about this here, what that means to enter an integer. It's actually received as a character, and what I'm going to do is I'm going to say while, and then serial.available, and it's a function, equal to 0, and then I'm just going to sit and spin. That's it. So it'll just sit there until something's available. And then what I'll do is if something ever comes up the cable, I will perform my serial.read, and that will assign it to that car variable vn. Okay, and then just to verify that something happened here, let's go ahead and say you entered blah, and I'll go serial.print vn. And it would be handy to do this over and over. So why don't I go ahead and let's do this. Let's put this down in this loop so it'll go forever. So once this is done, it'll say enter an integer. And then in order to see this variable amongst everybody, let's go ahead and pop it as a global. All right, so now I'm sitting here and I'm going to go ahead and fire this up, and we'll see what happens here. All right, so let me pull up the serial monitor as we're going here. And now we're sitting here. Enter an integer. So one of the things you notice is that if you click in the serial monitor and you try to type something, nothing happens. The way that you send something up is you have to actually put it in this little dialog box. So if I'm going to put 7 up here, and I have to actually send it. So I hit send, and it says you entered 7, and then it says enter an integer. So that was great. Okay, so life is good, except that my returns didn't work very well. So I'm going to say enter an integer. I'm going to print that as ln. And then I'll do this one, you entered, and then I'll do ln there. Okay, and let's run this one last time, and let's make sure that everything's cool. And life is good. Okay, so I'm coming along here, and what I want to show you is the difference. So enter an integer. So let's go ahead and send 7 up again. It says you entered 7. Enter an integer. I'm going 9. Life is good. 4. Check this out. I'm going to type G. It says G. Okay, well, it's fine. It's because it's a character. What would happen if I came up here and I made this variable vn an integer? Okay, so when I read it, it's going to say you're going to send something up the cable and it's going to interpret it as an integer. And since Arduino is going to allow us to use print right away, print on the variable and automatically figure out what type it is, what'll happen? So I don't know. I'm going to send 7 up and see what happens. You entered 55. That's kind of weird. What about 8? You entered 56. What about H? 104. What do you think's going on here? I'm typing it, I'm sending these characters, and it's giving me these weird responses. You know what it's doing? What comes up the cable is an 8-bit ASCII code for the symbol that you send. So when I say B, it's going to go look that up, and it's going to say, oh, the 8-bit code in decimal form for the symbol B is 98, and it'll pump that out. So you got to really make sure you pay attention to what, when you use the serial monitor to collect data, it's coming up as an ASCII character. If you wanted to use these as actual numbers, you would have to then, I would take it in as a character, and then I would convert from a character to an integer. Okay, so go ahead and play around with that. Do a for loop, do a while loop, use a for loop to go 1 to 10, print 1 to 10, use a while loop to do 11 to 20, and then use this while loop and this serial.available function to read a character from the serial monitor. That's going to be a big one. I mean, that's something that you can use like crazy. So go ahead and play around with that and pause the video and see how it goes. Alright, finally we're at comments. There's really nothing to say about comments other than Arduino supports line comments using -- or // and it uses block comments, supports block comments using the traditional C++ form where you have /*. And what that means is that here would be a line comment is basically when you do the // it will, everything after it is considered a comment. So that's a comment and it doesn't have any impact on the code. But then if you want to do a block comment, it's the same thing. You put that, and notice how everything else got commented out. So then I can come down here and end the comment. Everything in between these two will be comments. Okay, so at this point, experiment with those because at this point you want to start commenting your code. But that's everything that you need to know for the basics of the Arduino. We did all this stuff, software installed, running our simple hello world, but really to write something that does something important, you got to know data types and how the local global variables and how you can cast between them. You need to know the simple math operations. If-thens are a must, cases are a must. You have to have loops and you have to comment it. So at this point you have everything you need to know to use an Arduino to start doing real things. And that will end this video.